Good day to you all. Hope you are all doing wonderfully well at home. Okay, we want to continue from where we stopped in our last lesson, talking about application of integration. In today's lesson, we'll be looking at how to find the area under a curve using the concept of integration. And the few objectives we have are, you should be able to understand the steps involved in finding area under a curve. Then find the area under the curve by integration, and at the same time, sketch the curve of such a curve. Okay, when we talk about area under a curve, you agree with me that we can have the curve to be in the form, let's say f of x. Y is equal to f of x. The curve may form a shape like this. And we are now being asked to find the area of this curve under this curve. Now, like I told us in our last class, there will always be lower limit and the upper limit. Let's call this lower limit and the upper limit. If you want to find the area under this curve, how then do we do it? If you agree with me, that this shape does not form a regular shape. And since it is not a regular shape, the implication is there is no specific formula that can be used to calculate this area. Then we apply the concept of integration. How then do we do it? We need to slice this curve into a rectangular shape, simply because we know the formula to find the area of a rectangle. Now doing that, we have this. Okay, from here to here, as we usually put it, we have it to be delta s, which is the small change in x. Then since this curve represents our y, then every part on this curve is y. So we can say each length is y. That is, from here to here can be represented as y. Now, what is the area of this rectangle? You agree with me, we can bring out some regular shapes out of this irregular shape. That means we have as many as possible rectangles. But you still also agree with me, we still have some space left. That implies that we may not be able to have this as the accurate area under this curve unless something is done. Now, what is that thing? We reduce the length. And the process of reducing the length is what we mean by our delta s is tending towards 0, because the former delta s was as wide as this. Reducing it now will give us something very, very close to the area under that curve. Okay, once you understand that concept, when the curve is above, we have some cases in finding the area under the curve. Number one case is when the curve is above the x-axis. What do I mean by that? Like the shape I gave you initially. When we have that curve being above the x-axis, this is our x-axis, this is y-axis. Now we want to find this area. We have the lower limit, we have the upper limit. The formula is the area is equal to integral of the function f of x dx from the lower limit a to the upper limit b, which will give us all we have here. Then we have the second case, which is when the curve is below the x-axis, as we are going to be seeing here. Now let's say this is the x-axis. We have some situation whereby we can have a curve like this. Then finding this area now, what we need to put is our area is equal to negative of the integral of f of x ds from lower limit a to upper limit b. Now, what is then the difference between this and this? You just agree with me. It's just the presence of the negative sign in the second one. And you have to note that an area is always positive. Each time you have calculating area, you should always get a positive answer. But the negative sign you see here only denotes that an area is below the x-axis. Okay, once you understand that, let's look at the case 3. Case 3 is talking about when the area is between two curves. That is when we have this as our y, our x, and we have this as our y. We have a curve, this, let's say this is f of x, and we have another curve like this. Let's say this is function g of x. And we are meant to calculate area between these two curves. Now we can have, this is the lower limit, this is the upper limit. So this is what we are meant to calculate. How then do we calculate this? We calculate the area at f of x, we calculate the area at g of x, and subtract the area from g of x from that of f of x, and which will give us a which is the area, is equal to integral of f of x dx from a to b minus integral of g of x dx from a to b, which can also be written as subtracting function g of x from f of s before finding the integral. Okay, we have the example. The example here says, sketch the curve y equal to x squared minus 6x plus 5, and hence find the area under the curve. I want to believe from what you have done in your previous, I think, class, that should be SSS2 class, you should be able to sketch the curve for this function y equal to x squared minus 6x plus 5. What are the main things we need? We need the two values of x and the y-intercept. What is the y-intercept? Y-intercept is simply saying when s is equal to 0. So at point when s is equal to this is the curve, but the y-intercept is 5, so we have this one to be 5. Then you are solving this. Finding the value of x when y equal to 0, and by the time you have that one done, you are going to be getting x equal to 1, or y, and then x equal to 5. That simply means we have this point to be 1, and we also have this point to be 5. Now, the next question is, find the area under the curve. What is the area we are calculating? We are finding this. It's as simple as that. Now, to do this, what is the formula? We just go back to the formula that says when the area is below the x-axis, we put the negative. So, in that case, we will be having our area to be equal to integral of x squared minus 6s plus 5. Let's say from lower limit 2 to upper limit 3, then the x. So at the end of everything, you are going to be having this one to be, when we integrate this, you have x to the power 3 over 3 minus 3s squared, then plus 5x. And at this point now, you put your upper limit 3 and lower limit 2. From here now, you are just meant to substitute the value of x being equal to 3, substitute the value of x being equal to 2. And lastly, you are going to be having something like negative into 3 cubed over 3 minus 3 into 3 squared plus 5 into 3, all in brackets, then minus 2 cubed over 3 minus 3 into 2 squared, then plus 5 into 2, all in bracket. And your final answer will always be in square units. So with these few things we have done, I want to believe you have gotten the few steps needed in finding the area under curve. The remaining examples will be sent to you via Google Classroom, and you should be free to ask as many as possible questions you want to ask. Have a nice day. Bye.